Section 9.3, hypothesis test for a population mean and look at this, standard deviation, population standard deviation is unknown. And these are the objectives. Test hypothesis about the mean using the p-value method and using the critical value method. Two big things solving hypothesis testing is using the method, and I'm going to show you both for this section, but starting today, we're going to focus on just one method. After this section, for the next sections, the next chapter up until the end, we're going to use the p-value method, because this is what you have when you use your TI graphing calculator. Critical value is, you can still use your calculator here. You learn how to get the critical value, how to solve the critical value. Remember, Z alpha over 2 or T alpha over 2. These are the critical values. But every time we solve for critical values, remember, you need to use inverse norm for Z, or for T, you need to use inverse T. So we don't really need to do this all the time for all of the problems if we use p-value method. Because if we use a shortcut, your graphing calculator, you will already get the answer. It's already on the screen. Okay. So before we start with hypothesis testing with the p-value method, what are the steps in constructing your hypothesis testing? So let's review that again, and I want you to copy this. Number one is state your hypothesis. That is your HO and H1. That's step one. Step two is a level of significance, meaning that is your alpha. Most of the time it's given, it's on the problem. You just have to copy it, or if it's not given, automatically you use 0.05. Just like for confidence interval, if confidence level is not given on confidence interval, what do you use?
.25.
If there is no confidence level that is given,
is it 95%?
95% confidence level. You should always have a high confidence level. Even in taking this class, you should be proud of yourself, right? Be confident. I am 99% confident that I'm going to pass this class. Okay, so that's why you should always have a high number of confidence level. So for confidence interval sections, if it's not stated in the problem, you are required to use 0.95. Same thing for level of significance for hypothesis testing. If it's not given, you have to use 0.05. It's the complement of 95%, right? 1 minus 0.95 is 0.05. So take note of those two. Next, step number 3 is the test statistic. This is where you use the calculator shortcut and write the answer here. You just have to copy from your calculator either what your Z value or your T value. So for now, chapters 8, 9, 10, and 11 is either Z or T. That's why make sure that you use the correct shortcut. And then step 4 is the p-value. That's why we're going to use a p-value method. What is your p-value here? And the p-value is also, you will see it from your calculator. And then step number 5 is the decision rule. This is where you compare your p-value to your alpha. That's why you need to write your level of significance, step number 2. That's why you also need to have your p-value, because you're going to compare those for step number 5. Whatever your level alpha is, whatever your p is, you need to use it here. Okay, if your p-value is less than your alpha, this is reject the null hypothesis. If your p-value is greater than your alpha, is do not reject HO. And step number 6 is your conclusion. So just like an example from the activity yesterday, today, and you learned it yesterday, when you reject, you start with we conclude that, and if it's do not reject, then there's not enough evidence to conclude that. Okay, so this is what you're going to do all the time. These are the steps, and this is what you're going to show for every problem, starting on your test 3. Okay, make sure to copy these 6 steps. Also, by the way, when I grade your hypothesis testing, hypothesis test problems, it's always 10 points. How do I get these 10 points? So just to be clear at the beginning, hypothesis step 1, 2 points. 1 point for null hypothesis, 1 point for alternate hypothesis. Step 2 is 1 point. You just always have to copy this from the given. That's why you should not get a 0. If it's not given, you have to use 0.05, right? And then step 3 is 2 points, either your z value or your t value. The reason why it's 2 points, because this is where you analyze the problem and use the correct shortcut. And then if you know the shortcut, this is where you enter the data into your calculator, whether you needed to enter it into L1 or just the stats to get the answer. And also, step number 4 is 2 points. That's also after you use the shortcut, you will get this answer. So very important, steps 3 and 4, because this is where you solve it, where you use the statistical tools. And then decision rule, 2 points. 1 for stating if your p-value is less than your alpha or it is greater than alpha. Another point when you write the decision, either reject HO or do not reject HO. And then 1 point for conclusion, just 1 sentence. So that's all in all, 10 points for each. Okay? So that's how I grade your hypothesis test problems for all your tests, quizzes, last quiz, and your final exam. It's going to be 10 points each. Any questions so far? No? Using the p-value method, there are 2 things. Again, using the tables, and of course, you're using your TI graphing calculator. So we don't need these slides, this part, but I can show you. We're gonna use exactly the same problem when we use the TI calculator. Okay. Look at this problem. Let's start with this problem. We're going to solve it later with your TI graphing calculator. So we begin this section with an example. Suppose that a recent medical study, 76 subjects were placed on a low-fat diet. After 12 months, their sample mean weight loss was 2.2 kilograms with a standard deviation of 6.1 kilograms. Can we conclude that the mean weight is greater than 0? So this is one of the hints when to use hypothesis testing, when to show those 6 steps. There are only 2 things to remember. One is when you see this, can we conclude? This is not answerable by yes or no. When you see, can we conclude, meaning you answer this with just 6 steps. Okay? Because I saw before, whenever I see this type of problems, and you see, can we conclude? Some students will just answer yes, no. No, this is hypothesis testing. You have to show 6 steps. Okay, so that's the hint. The word conclude, meaning you're going to arrive at the very last step, which is your conclusion. And how do you conclude it? You have to show it. That's why you have those 5 steps before you write your conclusion. Okay. All right. So before that, like before we answer that, like what do you notice about this problem? What do you notice about this problem? You see that there is no
confidence level.
Population standard deviation is unknown, right?
Yep.
It's a sample standard deviation. So that's why this is 9.3. And like what I explained earlier, if, let's say, think about if you don't have this question here, and if I change this to, let's say, construct 95% confidence interval the mean blah blah blah. See, it's the same thing, right?
Yeah.
So that's why I said
Yes.
Those 2 sections are connected. I can use exactly the same data that's given, just change the question into a confidence interval problem. So that's why it's very important that you check the first thing, is it a confidence interval problem or is it a hypothesis testing? There are only two to choose from, either confidence interval problem or hypothesis testing. It's easy to check. Confidence interval problem, you will always see construct a confidence interval. It's already given. If you don't see confidence interval or even the word interval, if you don't see that, then it's hypothesis testing problem. Okay. All right. So before that, there's also an assumption. It's exactly the same assumptions. You don't need to copy this from 8.2. So we should have a simple random sample and n must be greater than 30, or it says on the given is normally distributed, or if the data is given and if you use the dot plots, you should not see skewness like skew to the left or skew to the right. Okay. All right. So we should start with our 6 steps. Step number 1. What's step number 1?
State the hypothesis, null and alternate.
Yes. Okay, so state the hypothesis, and we're going to write our null and alternate hypothesis. So here, the first one is, it says, can we conclude that the mean, the word mean, if we say mean, just to remind, if we say mean, meaning you have to use the population mean for your H0 and H1. If you say proportion, meaning you have to use P for your H0 and H1. Okay, so that's why you need to check, is it mean or proportion? That's another thing. For chapters 8, 9, 10, and 11, is it mean or proportion? Okay, so don't forget that. So mean, your H1, H1, if it's mean, you should use the symbol mu. If it's proportion, you have to use the symbol P. So letter A, so this is the mean, so it's mu, and the symbol for null hypothesis, remember, what is it?
Equals.
Equals. No matter what, is always the equal symbol. Okay, and based on this question, can we conclude that the mean weight is greater than 0? So meaning you are talking about this. So you just have to use 0 here. Greater than 0, so meaning that is your H1. Mu is greater than 0. Okay. Any questions with that? H1, H1?
No.
Okay, what is step number 2?
Level of significance.
Level of significance, alpha. Do we have an alpha given?
No, I don't think so.
So what do we use?
0.05.
Very good. So you just have to write 0.05 like this. Then step number 3, okay, I'm going to use this side here. And this is 9.3. And what's the shortcut here? T-test. So remember, this is similar to 8.2, whereas population standard deviation is unknown. For interval, we use t-interval, right? So for hypothesis testing, we use t-test. Okay, so I want you to try now. You get your calculator. So start test. Scroll down, look for t-test. I think it's the second. And then highlight stats. What do you see? You should see on top, you should see mu, right? You should see X bar, which is the mean, sample mean. You should see SX, meaning the sample standard deviation. And you should see N. You see mu, is it less, not equal to, less than, or greater than? Do you see this?
Yes.
Yes.
So make sure that you try it now on your own. Mu is, that is whatever you have on your hypothesis, your H or H1. You have 0 here, then you have to enter 0 here. Okay, whatever number you have here, you have to type it here. Then sample mean is given, it's 2.2. Then standard deviation is 6.1. And given is 76 subjects, so that's 76. And this part here, mu here is your H1. Whatever your H1 is your mu here. So mu is greater than the symbol. You just have to get the symbol. So that's why you have to highlight greater than. Okay, and then enter, you will get the answer. I will do the same thing here. Now, what did you get? We need to get the critical, no, the test statistic, which is the T.
T equals 3.14. I'm not sure how many decimal places are required.
Okay, did you get the same thing? 3.14.
Yes.
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 Yes. And then step number 4 is based from that window, you just have to copy this time. What's the step number 4 again?
Is it the p-value?
P-value. And the p-value is when you check your screen underneath the T, you see the P, that is the p-value. And this time you have to use 4 decimals. Excuse me. So this is
0.0012.
0.00, yes, 0012. Okay, so you just have to copy those two. Then step number 5, what's step number 5?
Decision rule.
Decision rule. 2 things to show here when you use decision rule. You compare your P and your alpha, steps 4 and 2. So you just copy it, 0.0012 and 0.05. It is 0.0012 less than or greater than 0.05.
It's less than.
It's less than. Okay. If it's less than, what did I say?
If it's less than alpha, you reject HO.
Yes. So you have to type reject HO. Okay. So you need to show 2 things for you to get 2 points. You compare your P and your alpha and then write your decision. There are only 2 to choose from. If it's less than, reject HO. If it's greater than, then do not reject HO. Okay, now we can write our conclusion. If it's reject, and write here. So we have a space. How do we start?
We conclude that.
Very good. Conclude that, and that is always from the question. Here is conclude that the mean weight loss is greater than 0. You just have to copy that. Conclude that the mean weight loss is greater than 0. And you're done. Please copy.
This is easier than I thought it's going to be.
And this is always going to be like this until up to chapter 14. So that's why I told you earlier, don't be scared. Even though it's 6 steps, it's not that hard. easy right now. So that's why, especially if, let's say for your final exam, it's a mix of all of the problems of all the sections, all the chapters. So that's why pay attention to what I always tell you, the hints. Like this one is a mean conclusion. We conclude. So this is the hint on what that you are going to use 9.3. Why is it 9.3? Because it is a mean. That's the first thing. It's conclusion, meaning you're going to write 6 steps. And based on the whole thing, this is just a one group, one sample. Here, there's only one N. That's what I meant about one sample. Okay, so that's the hint for you to use 9.3. It's easier to check if it has one sample or 2 samples. What I meant about 2 samples, you will learn that from the next chapter. You have 2 N's, 2 sample sizes. This one, there's only one sample size. Okay, let me know when you're done. Then we try the next problem. All right, done. We got that 3.14. You don't need to compute the p-values because when you use a shortcut, you saw it. You already have those that p-value. This is by using a table. This is how I learned when I was a student 20 years ago. We didn't have a graphing calculators. We only always use the table. Okay, next one. Who wants to read the problem? Volunteer.
I'll do it.
Okay.
Generic drugs are lower cost substitutes for brand name drugs. Before a generic drug can be sold in the United States, it must be tested and found to perform equivalently to the brand name product. The U.S. Food and Drug Administration is now supervising the testing of a new generic antifungal ointment. The brand name ointment is known to deliver a mean of 3.5 micrograms of active ingredient to each square centimeter of skin. As part of the testing, 7 subjects apply the ointment. 6 hours later, the amount of drug that has absorbed into the skin is measured. The amounts in micrograms are as follows: 2.6, 3.2, 2.1, 3.0, 3.1, 2.9, and 3.7. How strong is the evidence that the mean amount absorbed differs from 3.5 micrograms? Use the alpha equals 0.01 level of significance.
Right. Thank you. So how do you know if this is 9.3? The first one is about mean. Evidence, meaning, is about hypothesis testing. So evidence at the mean, and based on, if you read it again, there's only one sample size. What's sample size here? What's your N?
7.
7. 1, 2, 3, 4, 5, 6, 7. Yeah. You mentioned here, where's that? 7 subjects. Yeah, there you go. And then also, that's also again actually the easiest way to check if it's if you're going to use confidence interval or hypothesis testing. If there is a given alpha, meaning automatic, you have to use the 6 steps. If there is a given C level, confidence level, let's say 95%, 98%, 99%, you have to use confidence interval. That's another way. But of course, what if there is no given alpha, but still you have to check the question. Always check the question. That's where you get the hint. Okay, so here there's only one sample size, 7, and it's about the mean. So one sample size and about the mean, so that is 9.3. And there is no, as you can see, there is no population standard deviation. Okay, so actually, we checked about the assumptions. This is a simple random sampling, but n is less than 30. So if you graph this using box plots, actually the next slide, it will show that, I can actually show the next slide. You should see that, look at the, not box plot, dot plots. You can see that there's no there's no evidence of strong skewness. So we can proceed and answer this. Okay, so let's start with the first step. What is the first step?
Name hypothesis.
All right, sorry if I'm just getting some spaces. So you have to name HO and H1. You always get it from the question. So this is the question: how strong is evidence of the mean? It says mean, so that's why you have to use mu equals automatic for HO. And how about H1? What do you think is H1?
Not equal to 3.5
Why?
because it uses the word differs.
Very good. So differs is not equal to, and we use here 3.5. So you have to use that 3.5 for HO and H1. Okay. Then step number 2 is, I should know this.
T-test.
Level
No,
of
alpha
significance.
0.01.
Oh, yeah, wait.
So you
Yeah.
just have to copy it. Whatever the given, if it's given, you just have to copy 0.01. That's 1 point. Then step number 3, you have to use t-test. Now, this is different from the last problem because you have the data here. So meaning you have to enter all these 7 into L1. So try that now. Enter 2.6, 3.2, 2.1, 3.0, 3.1, 2.9, and 3.7. I will do the same thing with my calculator here. Check your numbers. It's very important. If you copy the correct numbers, and then the shortcut is t-test. And here, look for, scroll down and look for t-test, and this time highlight data. And you should see mu again, list, frequency, and mu. So for mu here is always check your hypothesis. You use 3.5, so this should be 3.5. The list is where you entered your data, so that's into L1, so that's in L1. Frequency list, we don't change this at all. It says 1, don't change that, okay? And then what do you need to highlight here?
Does not equal.
Yeah. Because your H1 is not equal to, so that should be not equal to here also. And then calculate, enter, enter. You should get the answer. What did you get?
For T, got minus 2.95.
I also got that.
And then for the
Me
P
too.
value, 0.0256.
I also got that.
Me too.
All right, sorry. 2.6, 3.2, 2.1, 3.0, 3.7. T-test. Oh, I didn't change my, sorry. What did you get for T? Sorry.
Minus 2.95.
So you just need 2 decimals. And then step number 4, copy your p-value.
0.0256.
Thank you, 0.0256. Okay, and step number 5, copy your p-value here, 0.0256, and compare it with your alpha. Is it less than or greater than?
Greater than.
Greater than.
Greater than 0.02, 0.01.
So with mine, I got the correct T value, but my P is different than others. I got 0.9872.
Oh, the reason why is go back and check this. You should have not equal to.
Okay.
I'm pretty sure that happens when you don't use the correct.
Oh yeah, it didn't, okay, it didn't change. That's what happened. All right.
Yeah.
Yep. Yes, that fixed it.
Yep. Mhm. All right. So since it's greater than, what is the conclusion?
Reject.
Our
Don't.
decision is
Yeah, you don't reject HO.
so do not reject HO. I forgot if your Connect math is either do not reject HO or fail to reject HO, either of the two. There's so many statistics books, they use either of the two, and they're both correct, okay? So you can use either of the two, fail to reject HO or do not reject HO. And then conclusion, if this is your decision, how do we start?
There is not enough evidence to conclude that.
There is not enough evidence To conclude that what do you think?
The mean amount of drug absorbs differs from.
Very good. Yes. So conclude that you just have to copy that. The mean amount absorbed differs from 3.5 micrograms. Okay, please copy if you need to copy this. Excuse me. Any questions?
No.
So for your Connect Math, don't expect that the problems are saying what are the use the 6 steps. You won't see that. You will see like let's say this is the whole problem. There's like a question, letter A, what's the correct hypothesis? Letter then what's the test statistic? What is the decision or what is the conclusion? So that's what you will see when you use Connect Math. So meaning we are combining everything in one, okay, for your quizzes and tests. Are you done? Questions? Is it too fast?
It's good pacing.
All right, let's go to the next one. So those are two types of problems that you will see on this section, either given the stats, the first one, or this second problem, given the data that you need to enter into L1. So yeah, there is not enough evidence to conclude. So that is the answer. So this is exactly the same problems. This is by using a TI-84. We already actually discussed all this. So you can revisit these slides to check again how to use those calculator shortcuts. So exactly the same thing. Okay, next one is by using the critical value. So the first one we use the p-value. This time is by using the critical value. I can show you both. How about let's solve this first, since this is a new problem. Let's just solve this first using the p-value. Practice, and then after that, a different way how to solve this using the critical value. Okay. Who wants to read the problem? Volunteer.
I'll read it.
All right.
A computer software vendor claims that a new version of their operating system will crash less than 6 times per year on average. A system administrator installs the operating system on a random sample of 41 computers. At the end of the year, the sample mean number of crashes is 7.1 with a standard deviation of 3.6. Can you conclude that the vendor's claim is false? Use the A equals 0.05 significance level.
Thank you. So look at the question. Can you conclude? So meaning that is hypothesis testing, and also there is a given alpha. So we have to use 6 steps. And here, there's only one sample size, which is 41 computers. And you're talking about, you see there is no population standard deviation. So how do we start with this?
State the hypothesis.
State the hypothesis. So how do we write our HO and HO1?
HO equals 7.1.
It would
Or
be
sorry, HO
6.
is mu equals 7.1.
Again, yeah, HO, if you're using mu, meaning this is population mean. But 7.1 is a sample mean, so be careful. So that's why we cannot use 7.1. What do we use here?
6.
Yes, it says here 6 times on per year on the average. Average meaning this is mean. So that's why we have to use mu. So HO equals 6 and H1 is so this is a little tricky.
Mu does not equal 6 because it says the vendor's false claim is false. It doesn't say greater than or
would-
equal.
It would be less than 6. It says it in the beginning of the problem.
All right, good arguments. Can you conclude is this is very important also, can it says here, can the question, can you conclude that the vendor's claim is false? What is the claim? The claim is the first
That it equals
that is less than 6 times per year on average, right? So can you claim, can you conclude that that is false? So meaning you have to get the opposite of that. So that's why it's going to be greater than 6. Less than, opposite of that is greater than. Okay. And then step number 2, I'll show you something later. Don't worry. Your alpha is 0.05. Then step 3, you have to use t-test here. So do that now. Enter your mean, standard deviation. You have your n. Six, 7, 6, 41. What is your answer?
Is it
For T, I got
1.95
That
or
is
1.95 round up?
so 2 decimals, 1.96. And your p-value
0.029.
4.
Oh, 0.0287.
Did you all get the same answers?
Yes.
Yes.
Yes, yes. Now, I want you to check now, go back to stat test, t-test, and change the mu to less than. Highlight less than. And let me know what do you see?
The
I
P
changed
value is
value.
different.
Yeah.
0.9713.
So it's the same t value. No matter what you highlight, you will always get the same t value. So there's nothing to worry about the t value, right? But your p is different. It's 0.9713. Do you see this? Yes.
Yes.
Yes. So this is also the hint that a p-value, this is based on my observations ever since, p-value cannot be this big. Always. If you're talking about one sample, if you're talking about one-tailed test, this is only for one-tailed test, meaning either less than or greater than. Okay. So remember this, p-value cannot be this big, or think about cannot be greater than at least like 0.9. If you encounter p-value that's something like this, even though if you use less than here, that's why you got this, right? So meaning this is wrong. All you have to do is change your H1, the symbol. So when you try at first less than, because maybe you didn't read the whole thing about the claim is false, because you see that is less than. Mostly you will use less than here, right? But when you use less than, you will see that it's a big p-value. And remember that you cannot have this big. So all you need to do is go back and, oh, if I got the p-value this big, so meaning my H1 is wrong. So you just have to get the opposite of that, meaning greater than. So when you highlight greater than, you will get this answer. Okay?
Can you review what was put in each of the different data points? Because I'm still not getting the right list.
Okay. When you use t-test, you will see mu, mean, standard deviation, n, and mu. Here is what is from your hypothesis. Whatever your hypothesis is, you have to use that 6 here. Okay, sample mean is from, it's given, sample mean is 7.1. Oops. 7.1. And then standard deviation is 3.6. And from the sample size is 41. And this is what I just discussed. If you try less than, you will get 0.97 something. So that's why you need to change it, highlight greater than. Okay.
I got it. Thank you.
Any other questions? Then step 5. What is step 5?
P
State conclusion.
versus the alpha.
Yes. So before you write the conclusion is you base it on the decision. So to write the decision, you compare your P and your alpha. So 0.0287 and 0.05. Is it less than or greater than?
Less than.
Less than. And if it's less than, what is the decision?
Reject HO.
Reject.
Reject HO. Very good. And now, what is our conclusion? Who wants to say about the conclusion? 6. Anyone? What do you think is the conclusion?
We can conclude.
that.
Go ahead. You're good. You're good.
So we
We
conclude,
conclude that the mean number of crashes is greater than 6 a year.
yes.
Is it also correct if you say that we conclude that the vendor's claim is false?
But what is the vendor's claim?
That it would be less than 6 times per year.
So yeah, so you have to mention about the crashes.
Okay.
Yes. Look at your H1 is greater than, so that's why you have to use greater than 6 times per year. Okay. Right. This is by using a p-value method. This is from the first method. The second method is by using the critical value. Although we're going to stick with a p-value method, but I'm going to show you how to use the critical value method. Okay. So for critical value method, it's still the same. You still have the 6 steps. The difference is you still have step 1, same step 1, same step 2, same step 3, but you have to solve it using a formula for T. And this is step 4 is not P, it's going to be critical value CV. And step 5, you cannot use this because we use P value here. You're comparing now your CV and your T. For P value, you compare P and alpha. For critical value, you compare your CV and your T. And then, of course, same conclusion. So to compute for your T is you have to use this formula. Mean minus sample mean minus the population mean over standard deviation over square root of n. So it's 1 point. That's why we got 9.96 when you use your graphing calculator. So again, if you're going to use critical value, you need to remember the formula. That's another thing, and you don't need to do that if you use a graphing calculator, right? So remember that T is equal to 1.96, and then now for your step 4, which is the critical value, we need to get, since what was the, sorry, hypothesis was mean is equal to 6, and this is greater than?
Yep.
Greater than 6. And if it's greater than or less than, we know that it is one-tailed, right? Greater than,
Yes.
meaning if, when you use a normal curve, it's on the right side, and this is the rejection region. If it's less than, it's going to be on this side. If it's not equal to, you have those two sides. Okay, so here, oops, since it's greater than, oops, should have something like this here, and then you need to solve for the critical value of t. What was the alpha given?
0.05.
Thank you. So this alpha here is 0.05. And to get the critical value, do you remember from the last chapter, how do you get the critical value of t?
Inverse norm.
T?
Oh, inverse t.
Yeah, very good. So it's going to be inverse t. So that's a critical value. Since it's one-tailed, what you learned before is we divide by 2, right? But if this is just one-tailed, so you just need alpha. So it's 0.05, meaning what do we use?
.95.
No, you still have to use your alpha. And I think inverse T, you need, oh yeah, it should be 0.95, sorry. Eraser, sorry. Because this is, if this is think about, this is 0.05, then this is 0.95. And when you use inverse T, is always to the left, right? So that's why this is 0.95. And then I think the other one is degrees of freedom. Is n minus 1. I think this is 41. So 41
Yeah.
minus 1 is 40. So try this. And you should get this 1.6868.
Yes.
Yes. So now, step number 5. So is the critical value. You use inverse T. That's for your step 4. If we are using the critical value method, then step number 5 is the decision. How do we write our decision? You compare. I told you compare critical value and step 3, t is equal to 1.96. You compare critical value and 1.96. So where is your computed t? Is it within the shaded part or not? So you're comparing your t and your critical value. Okay. Is 1.96 greater than or less than 1.68?
Greater than.
Greater.
Greater than. And this is 1.96 here. It's on the shaded part, and the shaded part is the rejection region. If it's on the shaded part, or if it's greater than, then this is reject HO. And then this is your conclusion. Okay, so that's another way how to use hypothesis testing. There are only 2 ways, p-value method or critical value method. Which is easier?
P-value.
P-value.
Value.
P-value, right? There's so many things to do this, because first thing you have to solve for t using the formula, and then number 4, solve for critical value, that is by using inverse t, and then the decision is comparing those two, and then to write your conclusion. Okay, so that's why I decided we just stick with p-value method for everything. Okay, because once you use the TI graphing calculator, when you use the shortcut, you will see the two answers, the t and the p-value already. Okay. So, oh yeah, that's it. Okay, that's it for here. I gave you those 3 examples. Those are perfect examples for this. Let's proceed to the next one, and then if we finish on time, then early, then I can give you more examples, or we have a lot of time on Monday to have more examples and review everything. Okay. So let's proceed to 9.4 and use the p-value method. Okay, section 9.4, hypothesis test for population proportion. This is very similar to 8.3 for confidence interval. If you remember 8.3, this is 9.4. This is confidence interval for proportion. This is hypothesis testing for proportion. See, they're related. And the shortcut, do you remember the shortcut for confidence interval?
It would be stat test and then 1 prop z
Interval. Since it's interval, right? Very good. And then for hypothesis testing, it's going to be 1 prop z test. See, interval test. Meaning confidence interval, this is hypothesis testing. Okay. And of course, these are the objectives using the 2 methods, the p-value and the critical value. So I already showed you how to use the critical value, and we are going to only use p-value method. But for these slides, we're going to use the critical value problem, use the p-value method as an example. Okay, so that's our goal. All right. Who wants to read the problem?
I can read it.
All right, thank you.
Can virtual reality be used to enhance education? In a 2016 survey of teachers conducted by Samsung, 85% of them stated that using virtual reality in the classroom would have a positive effect on education. One educational specialist believes that the percentage has now increased to more than 90% since virtual reality equipment has become more available. She samples 500 teachers and finds that 471 of them believe that virtual reality would have a positive effect. Can she conclude that the proportion of teachers who believe that virtual reality would have a positive effect is greater than 90%?
Thank you. So here, look at the question here. Can she conclude? So that's one thing. You're asking about conclusion. So meaning you need to write the 6 steps. And this is about proportion. So automatic, this is 9.4. Okay, so that's a hint. If you don't see the word proportion, you will see, look at the given values. You'll see 85%, you will see 90% percentages. So that's why that's another thing that it is all about proportion. So it is 9.4. And there is only one sample size here. There's only one sample size, which is 500. Okay, so that's why it's chapter 9. Chapter 9 is one sample. Chapters 8 and 9, one sample size, one sample. So that's why this is hypothesis about the population proportion. So that's how you check a problem when to use population proportion 9.4. Okay. Some notations, you don't need to copy this. These are exactly the same thing from 8.3. Your p, x, n, and p hat is x over n. You already know this. Assumptions is exactly the same thing from 8.3 because they are related. We have a simple random sample. The population is at least 20 times larger the sample, and you have the two categories, NP and n times 1 minus p are both at least 10. So exactly the same thing. And just to remind the 6 methods, step 1, state your null and alternate hypothesis. Step 2, your level of significance alpha. Step 3, this time is z. Okay, so when you use your graphing calculator, you will see z and the p value, c and p. Then step 5 is the decision. That is what you compare your p value and your alpha, and then of course number 6, state the conclusion. So these are the 6 steps. All right, so simplified question of that problem. Can she conclude that? So that is already given. Conclude the proportion. So this is a proportion problem and given the alpha 0.05. Okay, let's start. What's step 1?
State the hypothesis.
HO and H1. So what do you think is our hypothesis here?
So HO is P is equal to 0.90.
Very, very good. So this time it's about proportion. So meaning you have to use the population proportion P. So see the difference between this and the last section about the mean. So that's why we use mu. So this time if it's about proportion, or if you see percentages on the given, you have to use P. Percent meaning P. That's the easiest way to think about it. Okay, so this is the question. This is the question, the whole thing. It's about, it says greater than 90%, so you have to use that here for your hypothesis. So 0.90 and greater than, so greater than 0.90. Okay, so that's your step 1. Step 2, given, you just have to copy. Alpha is 0.05. Then step 3, so like what I said, the shortcut is 1 prob z test. It's z, so that's why we expect a z answer here. Okay, so please do that. Stat test 1 prob z test, and I'll do the same thing here. Where is 1 prob z test? It's number 5. You should see when you press stat test 1 prob z test, you should see P. That's from the hypothesis. Then you should see X, you should see N, and the prob. So P is, that's like mu earlier, we get it from the hypothesis. So you enter 0.90 here, not 90. Don't forget the decimal, 0.90. And then X and N. Based on the problem, what is your X and what is your N?
X is for
X is
91.
One. Sorry,
and n is sample
500.
500. Remember, and always remember this, x cannot be greater than your n because you're getting something from the sample. So it cannot be greater than that. So that's why if you mix these two, you're gonna get an error. So when you get an error, that means, oh, I mixed those two numbers. X cannot be greater than your sample size. Okay, and then prop is whatever your H1 is. So that is greater than. So highlight greater than. So do that and let me know your answer. Excuse me.
I got Z equal to 3.13.
Yes.
And then do we know P is equal to 8.7263?
Right. So be careful with this. P is that P value is with meaning that's proportion, that's probability, and meaning it's between 0 and 1. So all
Is
of
that the with the hat we're looking at?
what?
It's P.
So number 4 is that's on your screen below Z. So that's your P value, not the P hat. So here you see this, right? 8.726 something. And on the very end, you see E -4. Remember this before? If you
Oh, yeah, that's true. So B
write this,
0.000.
if you write this, it's gonna be wrong. I'm not gonna give you any points here, and I'll explain you why later. So that's why you have to make sure that you can copy this E -4, or this is, since it's -4, you move 4 places to the left. So that should be 0.008, like 7. Okay. Or another one, since you have E, let's say more than 3, -3, 3, 4, 5, 6, more than 3, instead of writing the whole thing, meaning you can write 0 plus. When you use 0 plus, meaning it is a very, very small number, but not exactly equal to 0. I will accept this because a lot of statistics books use this. But this book that we have, you won't see this, but I will still accept this, meaning it is a very, very small number. That's why there's a plus sign. A small number, but it's not equal to 0. Okay? So either of the 3. Okay? And also that should be, that tells you also whenever you see 8 point something, oh, P value cannot be that big. It should be between 0 and 1 only. Only between 0 and, no matter what, your P value should be between 0 and 1. Don't forget that. And the reason why I'm not going to give you points, and then you're going to lose a lot of points when you do not include this, or when you do not move it to the left, because if you use for your step 5, if you use that 8.726, definitely that's greater than your alpha, then you're going to have a wrong decision here, right? Do not reject HO. If this is wrong, if this is wrong, this is wrong, your conclusion is going to be wrong. See, you lost so many points already. You lost 5 points already here by writing the wrong P value. You don't want to do that. You don't want to happen that to your score just because of this. Okay, pay attention to that again. So if you see, because I see a lot of students that do not pay attention with this. If you do not, it will affect the everything, the fourth, the fifth, and the sixth steps. Okay. So when that happens, you're gonna lose 5 points. You're gonna lose half of your score. So that's why you can use 0.0087, or if you use 0 plus, and since it's a very small number, whatever your alpha is, it's still gonna be less than, since it's 0 plus. And if it's less than, we know that it is reject the null hypothesis. And if it's reject the null hypothesis, we always start with, we conclude that what is, how do you complete that sentence?
We can conclude that the proportion of teachers who believe that VR will have a positive effect on education is greater than 90%.
Yes. Thank you. You just copy it here.
One question about P, I rounded it to like 4 decimal places. Would that also be acceptable?
Yes, of course. Yeah.
Okay.
0.009, if you do that, yes. Any other questions? Let me know when you're done, and we go to the next problem. Okay. So that's what we got. These are all the same, exactly the same problem. Next is a critical value method. We're not going to use that, but let's use the example to use p-value method. So instead of critical value method, we use p-value here. Okay, p-value. Volunteer, read the problem.
A nationwide survey of working adults indicates that only 50% of them are satisfied with their jobs. The president of a large company believes that more than 50% of employees at his company are satisfied with their jobs. To test his belief, he surveys a random sample of 100 employees, and 54 of them reported they are satisfied with their jobs. Can he conclude that more than 50% of employees at the company are satisfied with their jobs? Use the alpha is equal to 0.05 level of significance.
All right, thank you. Okay, with this example, how about you try it first on your own? Okay, I'll give you time. Give it a try. So based on the question here, can he conclude that more than 50% of the employees at the company are satisfied with their jobs? It doesn't say here that it is the word proportion if you were looking for that, but based on the problems, you can see that 50% or even here 50%, meaning it is a proportion problem. Okay, and also based on the given here, you only have a sample of 154 of them report, so meaning this is your X and this is your N. And when you use a 9.4, you only need X and N, and of course your proportion. So that's why this is a 9.4 problem. Okay. Now, what are step 1, HO and H1? Anyone? Hypothesis? Excuse me.
P equals 0.50 for HO, and H1 is P is greater than 0.50.
Yes. So more than, so greater than 0.50. Very good. Step 2, the easiest one. What is step 2?
A is equal to 0.05.
That's correct. Then steps 3 and 4. You know the shortcut here is a 1 prop Z test. Z, so meaning you're gonna have a Z value and a P value here. So when you enter your X and your P and highlight greater than, what are the answers?
Z is equal to 0.6001.
Z is equal to 0.8.
I also got 0.8.
Yes, it should be 0.8. Try it again. And make sure that
I
you,
accidentally typed that 0.51 instead of 0.50.
it's the same thing. If it's 0.5 or 0.50, should be same. Make sure that this is this 1 prop Z test. And what is the p-value? I also got 0.80. So yes, 0.2119. Then step 5, we compare our P and alpha. Is it less than or greater than?
Greater than.
Greater than. And if it's greater than,
There's not enough evidence.
decision first.
Oh,
Don't reject HO.
yes.
Don't reject HO. And now your conclusion. You said there is not enough evidence to conclude that
that more than 50% of employees at his company are satisfied with their jobs?
Yes. So mostly you can get that from the question. That here, oops. More than 50% of the employees are satisfied with their jobs. Oops. Okay, very good. So yeah, every problem of our hypothesis testing, this is just what you need to show to me. Exactly these 6 steps. HO, H1, alpha. You don't need to write what the shortcut is. You just copy what the Z and your P value for steps 3 and 4. And then 2 things for number 5. To show if it's greater or less than in your decision, and number 6 is your conclusion. Any questions?
Nope.
About others?
No questions.
How is it? Easy? Difficult?
Pretty easy.
Surprised.
So yeah, at least on your test on Tuesday, since this is included on the test, and so far you just learned 2 hypothesis tests, and those are 2 different tests. One is mean, one is proportion. So this it's very obvious which one to use. So it should be easy on test 3. Okay, is it mean or proportion? Oh, all right. A good thing that you mentioned that. Yeah, I will open the practice test questions if you want that. Okay. Right after this class, I will open it, and then you will see that practice test questions. Okay. So yeah, so that is what we get. And that's it for this chapter. Finish chapter